Ever pondered why a radioactive material is dangerous, yet it's used in medical treatments and power generation? Well, the answer lies in understanding what radioactivity is. It's a process where unstable atoms release energy, kind of like popcorn kernels popping in a hot pan. Each pop represents an atom decaying and releasing energy, which we call radiation. Now, there are three main types of radiation: alpha, beta, and gamma. Alpha particles are like the giant popcorn pieces. They can't travel far and are stopped by a piece of paper or your skin. Beta particles are smaller, like the half-popped kernels. They can penetrate a bit further, but aluminium foil can stop them. And gamma rays? They are like the heat from the pan, invisible, penetrating and stopped only by thick lead or concrete. Now that you have a basic understanding of radioactivity, let's delve into its discovery. Scene script. Can you imagine discovering something without even seeing it? That's exactly how radioactivity was discovered. In the late 19th century, a French physicist named Henri Becquerel stumbled upon this peculiar phenomenon quite by accident. He was conducting experiments with uranium salts, which he had left on a photographic plate in a dark drawer. To his surprise, the plate was exposed, as if light had been shone onto it. This was puzzling, as uranium salts don't glow in the dark. Becquerel realized that the uranium salts were emitting something, an invisible radiation that could penetrate objects and expose photographic plates. This was the first observation of radioactivity. Now let's think of radioactivity as a flashlight in a dark room. Just like how the light from the flashlight allows us to see objects in the darkness, radiation can help us see things we normally can't. This has led to many real-life applications. One of the most well-known uses is in the field of medicine. Radioactive materials are used in a variety of diagnostic procedures. For instance, in a procedure called a PET scan, a small amount of radioactive material is injected into the body. This substance travels through the bloodstream and collects in areas of the body with high levels of chemical activity, such as cancer cells. The scanner then detects this radiation, helping doctors to see problem areas more clearly. Radioactivity also plays a significant role in our homes. Ever wondered how smoke detectors work? They contain a small amount of a radioactive element called americium. The americium produces alpha particles, which ionize the air in the detector, creating a current. When smoke enters the detector, it disrupts this current, triggering the alarm. And let's not forget power generation. Nuclear power plants use the heat generated from nuclear fission, a process in which the nucleus of a heavy atom, like uranium or plutonium, is split into two smaller nuclei. This heat is used to produce steam, which then drives a turbine to generate electricity. So, as we can see, radioactivity is not a villain, but a misunderstood hero, offering us numerous benefits. You might be thinking, if radioactivity is so beneficial, why is it considered dangerous? Well, just like a double-edged sword, radioactivity has both beneficial and harmful aspects. On the one hand, it's a powerful tool with many practical applications. On the other hand, exposure can lead to serious health risks, including cell damage and radiation sickness. Picture this. You're holding a glowing radioactive element. It's a source of great power, but without proper protection, it could harm you. It's like holding a burning ember. It can light your way in the dark, but if not handled correctly, it can also burn you. So, how do we handle this double-edged sword? We take precautions. For example, in hospitals, when using radioactive substances for medical treatments, they use lead aprons to shield against radiation. We also use distance as a safety measure. The further you are from a radioactive source, the less radiation you receive. Understanding the risks and taking precautions can allow us to harness the benefits of radioactivity safely. So we've taken a journey from the popcorn-like popping of atoms to the double-edged sword of radioactivity. We've learned that radioactivity is all about unstable atoms that break apart, releasing energy in the process. This natural phenomenon, discovered in the late 19th century, has found a multitude of applications in our daily lives. From medical treatments and power generation to archaeological dating, it's been a game changer. However, as we've seen, radioactivity is not without its dangers. Exposure to high levels of radiation can lead to serious health issues, making safety precautions essential. We need to respect and handle this powerful force with care, balancing its benefits against its risks. As we've discovered today, radioactivity is more than a plot device in science fiction. It's a complex and fascinating science that plays a vital role in our modern world. So next time you hear about radioactivity, remember it's not just about glowing green substances in sci-fi movies. It's a complex, fascinating, and vital part of our modern world.